Hello.
Hi. Hi, good afternoon.
Good afternoon. How are you?
I'm good, thank you. How's your
Yep.
day going?
It's going well. It's pretty sunny today for me.
Okay.
Um, yeah, sounds good. So, we have an hour together for a coding session. Is that correct?
That is correct, yes. Yes.
Yep. So I've got a couple questions prepared, but I'd like to ask you if you prefer a harder problem or an easier problem.
Uh, I think let's go with an easier problem.
Oh, okay, sounds good. So let's start with that, and
Okay.
then if you've seen the problem or you don't like the problem, just let me know. I will switch it up.
Okay.
And depending on how we do, we'll just keep, tweaking the question, adjusting to the difficulty of the question for the next one.
Okay.
With that, let's get started. Can you pick the language that you will be
Yes.
using for this problem?
Sure thing. I'll use Python 3, let's say.
Sounds good. All right. So let me put the question up here,
Okay.
and here we go.
Okay. Okay. So I will read the question loudly. Is that okay?
Up to you. Yeah.
Okay. So given an array with n objects colored red, white, or blue, sort them in place so that objects of the same color are adjacent with the colors in the order red, white, and blue. Okay. Here we will use the integers 0, 1, 2 to represent red, white, and blue respectively. Note you are not supposed to use library sort function for this problem. Got it. So if the input is like this, supposed to get 001122. Okay, cool. I see. Okay, I think I understand the problem. I definitely understand the problem. Um, um, so I think I'll just start talking about the problem. Just ask some questions, thinking out loud. Essentially, the array is given. It has only three kinds of elements. Either it'll have a zero or a one or a two. My job is to do an in-place sort of the array. That means I cannot use an extra data structure. Like I cannot use extra space other than what is given to me, which is an array. So that means I can modify the input array that is given to me in place, which is what the goal is, sorting in place. Another thing is that I cannot use any library functions. So basically, it's an algorithm from first principles trying to sort the array that is given to me in place. Okay, so I am thinking of various sorting algorithms in my mind at this point. Um, I think the some of the algorithms that do in place sorting is what insertion sort, bubble sort, uh, those kinds of algorithms. Their complexity is O n square. Trying to think of quick sort. Quick sort. Actually, quick sort is a little bit hazy in my head. So but I think quick sort also does it in place. Definitely does it in place. The input has to be randomly sorted to start with. Otherwise, if it is already sorted, the complexity could be O square. Merge sort is a recursive algorithm, better implemented recursively, actually. Does it do in place sorting? Probably not, I think. Or maybe it does. It can be implemented to do in place sorting. Okay, so I'm trying to think what is the right way to do this. Um, so obviously the runtime uh, is is should be as low as possible. So basically, trying to rule out insertion sort and bubble sort because they would be n square nested loop algorithms. Trying to think if I should use quicksort or try to build an implementation for in-place mod sort, um, or if there's anything else I can do. Mm, yeah, I think at this point probably quicksort is the quicksort or merge sort are the best algorithms, but unfortunately, quicksort I'm hazy on quicksort. Merge sort uh, is merge sort. I think I remember the algorithm, but I think I'm a bit rusty on that too.
Yep,
Uh,
yep. Let's pause for a little bit here. That was actually pretty good in terms of coming up with so many different sorting algorithms here, and then sort of comparing all of them, the pros and cons of each. And that was good to kind of see that discussion there. It was more one-sided, but it was good to see that survey of algorithms. However, one thing I wanted to point out there is that this problem is a little bit different than what you're envisioning. I see that you're seeing a sorting question here. In many ways, that's true. We are trying to sort some values in the list, but
mm,
keep in mind that there are only three types of values, right?
mm,
Everything that you've talked about so far applies to an array of many values, right? That's why you need
correct.
a sorting algorithm. Here, if we have three values, um, and you know that there's only three values at most, right?
Mm,
Um, can you think of something much easier than sorting algorithm?
I see. I see. That's a good hint. So I'm trying to think. Also, think of something easier than a sorting algorithm. Okay. Um, Something easier than a sorting algorithm. Um, mm, I'm so what I was thinking in my head is, something like swapping. If I, as soon as I see an element, I swap it. Like, see, I start with a two here, and then I see a two, so it has to go to the end. So I swap it with a zero, and then I get a zero, and then I zero on index one. Then I let it remain there. Then I get a two, but what do I do with that two? Because if I swap it, it's not gonna help me much, even though I can do it as a no op sort of a step in my algorithm. But what do I do with the one that comes after two after that? So I I think I'm not quite getting the algorithm in my head. I have not quite been able to wrap my head around this yet.
Okay. Okay,
Mhm.
that's
Mhm.
fair. What you've been describing so far with the swapping and then seeing the zeros and twos, that's actually a very feasible solution. Obviously, it requires a few tweaks, right? What do you do with the one? What happens when you do a swap, right? And then you see a two later on. What do you do? These are actually questions that you need to answer in order to solve the problem this particular way, which is um, moving the two to the end, moving the zeros to the end, and then leaving the ones in the middle. That's one approach that you can explore further if you want. Another approach for a problem like this is that let's assume that you can visit the array in two passes, right? Let's say in your first pass you are collecting some statistics, and then in the
Mhm.
second pass you are using these statistics to actually sort the array. If you think about it like that in that sort of template, can you think of a way or an implementation to actually solve this problem?
Right. So I think so when you said two passes, okay. So in first pass, I'm supposed to be collecting some information about the input, which I can use in my second pass to actually sort it the way the problem requires. So what kind of two-pass solution I can think of? Um, is it a count? Mm, my indexing. Am I trying to get index of every place where two occurs? Um, um, so let's say I get an index of all the places where a two occurs. Will that help me at all? 0, 1, 2. So let's say 0 and 2. Um, count. It. I think it can. It can. I see. I see. I think it can. So what I can do is I can do a count. I can say, okay, 2 appears 2 times, 0 appears 2 times, 1 appears 1 times. So essentially just merge 3 lists, 0 multiplied by 2 plus 1 multiplied by 2 and 2 multiplied by 2. So that would be the answer.
Yeah, that sounds like a very feasible solution as well. Before you start coding, what would be the time complexity and space complexity of this algorithm?
Right. The time complexity. So in my first pass, I iterate over it. So that's O of n. And then I don't need a second pass uh, really on the array, but since I created my data structure, which is a dictionary, I'm thinking, or a counter, so I need to iterate over it, and so I need to iterate over it. So that would require an iteration. So O of n, it would be upper bound. So upper bound is O of n. So that is the time complexity. I have the upper bound is O of n. Now space complexity. Coming to space complexity. Now actually the problem said in place, but I'm using extra space here. The space complexity would be upper bound for space complexity would be O of n, because essentially I'll be creating a dictionary saying, hey, 0 appears 5 times, or 1 appears 7 times, and 2 appears 9 times. So that is one thing where I'll be using space upper bounded by O of n. But there is another place where I'm using where I'm creating using extra space, which is when I create my list. Let's say when I say 0 appears 5 times, so I create a list with all zeros, then I create a list with all ones and all twos, and then I merge it together. So that is a new list that I'm creating. So I'm creating a sublist and then I'm combining them. So I think the O of n and O of n, the time and space complexity, that is what I think.
Yep, yep, I follow you on the assessment there. Based on what you are implementing, I agree with you. It's linear time and space. Uh, However, on the space side, I think we can tweak a little bit to make it better. First thing I'll point out is that you said you're going to use a dictionary to keep track of the count. But from what I hear from you, you are keeping track of 0, 1, and 2. So there's just 3 entries. And no
Oh,
matter
yeah,
how long the input is, it's just 3 entries here, right?
correct. Yes.
So that's one first observation there. The other is that you said you are creating the list and then merge them together.
Hmm.
What if you don't create the list at all, right? What if you just have to count, right? Let's say there's two ones, two zeros, and two twos, and you just have three numbers, right? Twos, twos, and twos. Are you able to recreate the sorted list with just these numbers instead of creating a list and then merging them?
Yes, yes. In fact, I can just modify my original list. Once I have a count, I can go over I can just say, hey, put all zeros first, these many zeros, then put these many ones, and put these many twos in the original list itself. So I don't even have to create new lists and later on merge them. And I
Right,
can use, yeah, I can use variables to do the count. I don't need a dictionary.
right. Sounds good. So now with all these optimizations, what would be the final space complexity here?
The final space complexity, so I'm using three extra variables. So that's constant because we could say it's three, right? So O of three. So I think that's constant. So space complexity would be constant. Time complexity would be first pass, I need to do a count. Okay. And then in second pass, I'm going to iterate over the three variables and modify the original list. So I think O of n, the time complexity would be O of n.
Yep, that's good. So I agree with you. I think time complexity is order of n. There's no, you cannot do better than that. Space-wise, it's constant, so that's good. So with that, I think we can get started coding this up and then test it out to see if it works.
Sure, sure. All right. So I will start writing my code saying def sort sort array, let's say. So this, and this will be my array. And then what I'll do is I need to do a count. So map, I'm trying to think if I can use map here. No, I don't have to. For so zeros zeros equal to ones equal to twos equal to zero to start with. Mm, and then for I in ARR, if I equal to zero, then zeros plus equal to one. L if I equal to one, ones equal to else. Yeah, I guess I can just make an assumption here. I'll have only three input types, so else twos if I equal to one, elif, not elif. Okay. So that is this, and now how do I assign? Trying to avoid writing three loops basically, or what I'm thinking is now I have these counts in three different variables. How do I use it to populate the array? And I'm also trying not to create an array and assign it, like slice the original and assign a new array to that slice, um, because that would that would require more space. Um, so mm, what I can do is, okay, so for I in, I don't want to create another variable. Maybe I can define a function. Maybe let's define a function def populate. what will I do here is for I in range var um, starting index would be index idx. I think I'm making it more complicated than it needs to be, but I'll try to attempt this way for I in range var. So essentially what will happen is perhaps I have a syntax error here. I thought Python allowed this. Try it out. Oops. Yeah, it allows it. So I don't know why it is. Okay,
Yeah, I don't think you
so
need to worry about it. The red squiggles will go away when you write something inside the for loop.
I see. I see. So now what I am saying is thinking is populate. So idx will be equal to populate. I have to give it the array, and then I have to give it the var. Var would be zeros, and starting index will be 0. So then what I'll do is for I in range var um air idx um plus I index plus I. Now I have to also select what to populate with 0, and then so this is how it will populate first, and then what will happen is when I, so let's say it's 2, so 0 and 1, so then I have to return, what do I have to return? I have to return the index coming back, so 0 and 1, so then 2, so return idx plus uh, I plus 1, that's the starting index. And then also I need to return ARR, modified ARR. So then I go here and I say ARR, and the IDX would be IDX. Let me set IDX bit to begin with to be equal to 0, and then this, and then zeros, IDX, and 0. Ones, two WO2s, and let me just put it here, return ARR, like this. So IDX equal to 0. So let's see what I have done here. 0. So I send a 0 there, okay. And IDX is the starting index. Then so 0 and 1. So let's say index plus 0, index plus 1. I set it. Oh no. Value. I have to say value here. And then I say value. So I set it there, and then it comes out of there. So my next is index. Starting index would be given index plus I, the current value of I plus 1. So I go there. I think this looks, perhaps there's a problem, but let's see. longer needed. Sort array. This print is a function. And if I do this, let's see what it gives me. Mask hedgehog. Okay. So yeah, I think it is giving this, but let's see. This, what does it give? Yeah, local variable I referenced before assignment. Okay, what happened? xi plus 1. What happened? Return local variable I referenced before assignment.
Hello? Can you hear me? Hello? Yeah, I don't think I can hear you at this point. If you can hear me, can you type something? Okay, I'm having a little bit of audio issue here. Let me rejoin. Hello? 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 Okay. Can you dial in? There in the bottom right corner.
Hey, can you hear me?
Yep, I can hear you now. Perfect. Oh,
Okay, cool.
thanks. Yep, it's good that we can recover from that audio um, problem there.
Yeah.
I like to call it audio Mageddon. Anyways, I think we're testing, and we saw an issue with your second test case, which is good, by the
Correct.
way. Your test case is able to reveal a bug, so let's try to debug it, and then I think you're very close.
Sure. So actually, the bug is because if if I don't have any zeros, then this is 0. The loop doesn't have any iterations, and I doesn't get initialized. So then when I try to add an I, which is non-initialized, so it throws an error there. So that's the reason for the bug. I am trying to think.
Right.
Trying to think if there is a better way to do this so that I can avoid all these issues.
Yeah. No, I think what you have is pretty good, right? If var is 0, right, then maybe we can return something before the for loop.
I see. Yeah, just check if var is 0. Okay. Yeah, I can try that. If var equal to 0, which means no count, then yeah, I can just return my current index and current array. IDX. Yeah. Yeah. So let's see if this gives something. Okay, this seemingly worked, definitely worked. 222 should be a trivial case. Just this all should work. Okay, the more interesting case would be an empty list, and maybe I can comment these ones out. Okay, so I got an empty array, which is nice. If I get a 0 there, if I put a 0, let's see. Well, I'll just run all 4 of these. It shouldn't take much time. Be quick. 0, 1, 2. Okay, so they seem to have worked. Let me comment that out. This. Okay. Now, what else? What else is a good test case for this? So empty single values, multiple repeated values, mixed values. Yeah, there's another one that I'm missing here, where let's say I just have a 0 and a 2 in here, or just this, like this. There's no 1. So it should just work. Okay, this should also work. And let's say if I give an input in a different order, so let's say 2, 0, 2, 2, like this. This is commented out. Okay. Yeah, this seems to work so far. Yeah.
All right. Yeah. Let's end there for this question because I do want to ask you a second question.
Sure.
I'll give you some feedback on this problem, and then we can quickly move on to the second problem. How's that?
Sure. Sounds good. Thank you.
Yeah. All right. So I think this problem is sort of considered on the easier side, but it was great that we had some discussions in the beginning of various approaches. One thing I really like is that you are able to take feedback right away on the directions that I'm trying to steer you towards. Mainly that there's no sorting algorithm necessarily for this problem. You can make use of the fact that there's just 3 values. You can use some sort of count. You quickly came up with an approach similar to that, and then we are able to also optimize that. And just overall with that discussion, I see that you're able to make progress as I give you a little bit of hints here and there, and that's a good sign because you're able to kind of move to the right direction, right? And then that's perfectly normal. And I really like that when you're writing the code, you are very quick in identifying, sort of computing the count. And the next part is you recognize that you don't want to repeat writing the same code 3 times. So you put it into refactoring the separate function that does that job once, which is good because you're using the try principle. And I don't see a lot of people do that, by the way. So that is good in terms of the coding style. and obviously there was a bug, and your testing was again great in order so that it was able to reveal that bug, and you're able to take a quick hint to just solve it, fix it. I say so that was good. Unit testing is very thorough. You consider so many cases. If I didn't stop you, you might be continuing with that. That's good, but sometimes it can be a little bit bad in the sense that you need to manage your time well. Because in a real interview, you might be expected to solve two problems within a certain amount of time. So you really need to look at the time and say, okay, how much time do I have left for this problem there, right?
Right.
But besides that, the thoroughness was there. The unit testing coverage was there, which is great. And we talked about the complexity analysis there. So with this question, I think you're able to take some hints, take some feedback, and demonstrate good coding style. You got the right answer, good testing. So I think there's nothing major improvements needed here at all, except that maybe a little bit more on the time management there, just to be aware of how much time you have left, and then just be a little bit quicker on the unit testing. Just don't take your time, but like go a little faster there. But other than that, I think within half an hour to solve this problem is reasonable. Again, also depends on the company. Sometimes they expect you to do it in 20 minutes. But I think 20 to 30 would be reasonable. You spend a little bit more, then there will be a bit of a risk in terms of the timing of solving this problem. Any questions for me before we move on to the next problem?
No other questions. Thank you for the detailed feedback. That was very helpful.
Okay, great. So let me paste the second question down below in line 50, and then
Sure.
we can get started. So this one, I need to draw a little bit of a picture here for you. But go ahead and read it.
Okay. So I'll start by reading the problem aloud. Okay.
Yeah, sure.
Okay. So given all the nodes of an n-ary binary of an n-ary tree as an array, node tree array of type node, okay, where each node has a unique value, okay. So let's say I have this is a tree, and it's an array is given containing all the nodes. Find and return the root of the n-ary tree. Okay. Return node 1. Okay, because 1 is the root node. Got it. So now this is a class node. Okay, array of objects of type instance objects of type class.
Yeah.
Okay. So basically init self wall and children none, self dot wall equal to wall, self children equal to children. If children is not none, self children equal to children. If children is not none, else it's an empty array. Okay. If it is none, then it's a empty array. So children is a hello. Can you hear me?
Yeah, I can hear you
Okay.
perfectly. Yeah.
Okay. Thanks. So children is an array then, right? It's an array.
Yeah. Children is a list of nodes. So
Yeah.
yeah, it's an array. Yeah. So this
It's
represents
a
the n-ary tree, right?
n-ary tree. Correct. So now what? So essentially the class node and then find root. So tree, self, and tree. So I'm supposed to return an object of type node, and I'm given a list of objects which are instance objects of type node, right? That's what I'm given.
Yep. You are
Okay,
given an array of nodes. Yep.
array of
Yep.
nodes. Okay.
Yeah.
Okay, so if I'm given an array of nodes, oh, and each node has some children. Okay, I see, I see. So
Yeah.
basically, if I'm given one, then my object one would have the self dot val equal to one, and children will be object representing 2, 3, and 4, and then my so that's my, let's say, first node, and then I'll have second. So my uh, my object 2 would have wall equal to 2 and children as 5 and 6, and 3 would have 3 and empty, 4 would have 4 and empty. So that's how it will be. So, and I'm given an object, an array of node object 1, 2, 3, 4, 5, 6. So, and then 5 and 6 will have 5 empty, 6 empty, like that. So that's how it is, if I'm understanding correctly. And then if I'm given this array of objects, I have to figure out my child node. Okay. Now the 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 thing to notice here is that I could so I can identify the leaf node very easily, because the leaf nodes will have no children. So that is easy to identify. Now, if I have, and so the nodes, okay, the nodes have children. We can identify the children. So if I have a 5, I can tell it's not, it could be a root node if it's only a tree with one node. So it could be a root node and a leaf node at the same time. Okay. So how do I do this? So okay, let me see. So 5 and 6. If I get a 3, so let's say I start with a 5. Find root. Okay. So 5, I can look at the well. There are no children. Okay. Oh, but since I know the length of the list, I can tell whether it has how many nodes it has. So if it has more than one, then obviously the node I'm looking at, if it has no children, it's a leaf node, so I can ignore that. Let's say look at 6. 6 can same thing with 6. Same thing with 3 and 4, so I can eliminate, let's say, 5, 6, 3, and 4. I know a way to eliminate them. Now, then I have I have I have 2 and 1 remaining. So 2. So basically, the root node is the node that is not a children of any node. So that is what I'm trying to find. Amongst these lists, I have to find a node which is not a child of any node. Now, so what is this? This is this sort of a breadth first search type of question, if I'm getting this correctly. So basically, it is like a graph. I have an adjacency list where so I know 2 has children 5 and 6, but I don't 5. So 2, I have to check if 2 is a child of any node, and so Okay, so I start with 2, let's say, and I say 5 and 6 are children. So I ignore 5 and 6. And
Okay.
then I go to 3. Um, 3 doesn't have, 4 doesn't have, but I go to 1. So essentially, so let's say I start with a node and I look at the children. And whatever children, if I find children, I store that value. I store the value of the children in a say a list, let's say. And then as I'm iterating, um, and so I say, okay, I got a 2. I'm iterating on my master list. So I say, okay, 2, what children do you have? So I have 3 and 4. So 3 and 4 cannot be the root nodes. So I put it in that data structure. So then, but 2 could be, 2 could be. So then I go to another one. I say I come across 3. I come across 3 and 4. 3 and 4 cannot be. 3 and 4 don't have children. Um, 3 and 4 don't have children, so nothing to do there. 1, then I get 5 and 6, nothing to do there. Then I get 1. So 2, so now I can add, so 5 and 6 are already there in my list, which are not root nodes. Then I can add 2, then I can add 3 and 4. So I have added 2, 3, and 4. And then I get a 1. So 1 is not there. So then my trimmed list then I need to iterate again over is 1 and 3 and 4. No, just 1, because 3 and 4 are already excluded. So I think that's how I have to do this. It's like I iterate, and if something is a children, yeah. Okay, so my algorithm is like this. I start with all the nodes, then I take a node and I find out what its children are. I get the values. Now I take the children and put it in the data structure. So my first iteration will essentially, I'll iterate over all of them and I'll try to figure out all the children. And then in my second, and then what I have to do is from my original list, I need to remove all the elements that have whose values appear in the list of child nodes. And then I continue doing this till I'm only left with one node in my main list that I'm iterating over, and then I return the value of that. So that is my root node because it has no children.
Okay.
So
okay. A couple clarifications here. The function that you need to write returns the node, not the value, but the node.
I see.
So, and then the other thing is, I follow your algorithm here, but the last part where you are iterating on a second pass to remove the node that is in your data structure, I want to know why that step is necessary, that you have to remove something from the input list. What if you don't? Are you still able to get the answer if you do not remove?
I think yeah, you're right because because I can just do a sort of a set subtraction from my, so convert original list into a set, the children list into a set, do a subtraction, and that will give me the nodes or a node that are not children, and that would be my root node at that point.
Okay, sure. Yeah, you can definitely do a set subtraction there or a set difference there. Okay,
Yeah,
so there's different ways of doing it. I think we have the time to code this up quickly, and I can help you with writing the unit test or like setting up the tree to test it. So if you can start with writing the actual main function, that would be great.
sure, sure. So, oh, find root, you have already given me the prototype. Okay. So find root, uh, here I have this, and then what I have to do is for node in tree, um, if if node dot children uh, okay, what was I finding? I was trying to identify nodes which are children. So okay, so if node dot, okay, so what first I have to do child nodes. I have to do this. This is this. Now for child in node dot children, child nodes dot append child. So what I did here is for node in tree, for um, yeah, so else it'll be node dot children. Oh, it'll be none. Okay, it'll be if children is not none, then children. Okay, it's an empty list. Okay, it will not be none. Okay, got it. So then, so 5, let's say I got a 5 and 6, it will be empty. Then I got a 2, it'll add 5 and 6. Then I got a 3, it'll be empty. If I got a 2, it'll be empty. 2, I'll add 5 and 6, 3 and 4. Then when I get a 1, I'll add 2, 3 and 4. So that's how it'll be done. So I got my child nodes. All my child nodes are there in here, and once I have that, so now we are coming to what you were hinting me at the beginning. You were saying that how do I, so now in one pass I found all my child nodes. Now how do I know my root node? Because my root node is now still, so my tree has one extra node and my child nodes has all the other child nodes. So, and what I was saying is I can do a set difference. I think you had a different idea, but I'll just go with that. What I was thinking, perhaps it'll come to me later. Set child nodes like this, return. I think this should do it. If I were to do find root, let's say, with a list of nodes. So, okay, how do I do that? It's a list. Okay, so new node, new node, let's say 1. What value? Yeah, I'm sending a value of 1, and my children are a array, so those are an array. Okay, this can get complicated, so I'll do.
Yeah. Yeah. Don't worry about the time. Will take a little bit longer if necessary. Just focus on the coding and don't worry about the time.
Sure, thank you. So I have new node 2, which is my 2. I'm trying to set up 2, not start with 1. So then a new node value is the children are 5 and none. So that is 1, and then this. So let me copy paste. C V and then 6. So let's say I start with this trivial case. So I just used a subtree like 2 and 5, and I'm hoping I will get 2 returned. Let's see. Invalid syntax, right? New node. I think I made a problem in the constructor somewhere. What is the problem here? So new node none, node this. Did I miss this? Yeah, maybe this. No. What am I missing here?
Do you need new in Python when you create a new object?
Oh yeah, you're right. Sorry, new is in Java. I'm sorry.
Yeah. Yeah.
Yeah. Unexpected EOF while parsing. This should be easier to fix. Like this. List is not found. Oh, did I create list? Find root. Oh.
Okay. Yeah, I think the self there might be throwing you off a little bit. I think this is not part of the class, right? The find root. Do we need the self? Maybe we'll need self there. I'm not too sure with the syntax itself. I think we can remove that.
Yeah.
Ooh, that's bad. Looks bad. I'm gonna leave it there. What if we just remove this whole kind of Java Python 3 syntax here and just go with this? Would that work? Missing?
No, I think this was good. I mean, here we can just print the value because I think this is the object.
Okay.
Node object with value 2.
Okay. Oh yeah, I think the square brackets here maybe is. Oh yeah, I see why it's needed. Yeah, because it's. Let me see. Oh, I think I know what's going on. Okay, I see what's going on. Let's break this into parts. I think what's happening is that you created a tree, right? And I think the tree is 2, 5, and 6, right? That's the tree that you create, right? Let me just take it out. Yeah, I take it out there, and we're not passing all the nodes into the input. I think that's what's happening. So this is the tree, right? Let's just call this the root, right? I think I have everything. Maybe missing bracket. Oh, how do I do this? Okay, so this is the. What is this? How come we have another bracket here? I see. Okay, I think this is going to be a little bit hard to create. Let me. Yeah, I thought I said I was going to create this. I forgot. I didn't do it. Sorry. I'm going to recreate the tree with the 2, 5, and 6, and then we can do this. So let's say node 5 is 5, right? Node 6 is node 6, right?
Correct.
And then
Correct.
node 2, let's put that in the bottom as the root, and then let's just say uh, node 5 and node 6, like that, right?
Correct.
That's clear,
Correct.
right? So now we're going to pass in the input as an array. I'm going to say node 6 first, node 5, and node 2, right? And we pass in A. That's all we're passing in, right?
Okay. A is the
So A is the array, the input array of all these nodes, where these nodes together form this n-ary tree, right?
correct. Correct. Yeah.
So let's see how this goes. Let's run it. I hope this runs.
So we need a node 2. We
Oh.
need a node 2 here, the variable node 2.
Oh, yeah, it should be 6, right? Yeah, I meant to put 6 there. Sorry. Oops. Root. Yeah, right. I meant to put root there. Not root.
Okay,
Root.
cool. Yeah, this will be
Now,
good.
yeah, now we should get. Should we get
We can
something?
delete self. We can delete self.
Okay.
We don't need
Yeah,
self.
yeah. Okay.
We need self.
All
Yeah.
right. All right. Let's do this. Oh.
And
Ooh.
it takes 1, 2,
Ooh.
3 positional.
Which one is that? 85.
Oh, we need node 5 and none. Oh, it should be a array. Like the root node 5 and 6 should be in an array.
Why? Oh. 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 Yeah. Oh,
Yeah.
that's how you do it. Oh, got it. Oh, okay. Okay.
So now,
Ah.
yeah, now we can do a dot val. It should print a 2
Oh.
in the print.
Ah. Okay. Okay. Yeah. Go ahead and do that. Oh, are you talking about line 78? Is that the problem?
Line,
Or...
I was talking about line 87 actually. I was thinking
Oh.
if I did this, it should
Oh.
print
Okay.
a
Yeah.
2.
Yeah.
Oh,
No.
did I return a set?
Yeah, it's returning a set. So maybe get 0. I don't know. How do you get the first item of a? Oh, maybe like just Let me do this. Let me do this. I think I got an idea like that, and then that val.
Right,
Maybe.
right. Yes, exactly. Yeah. Oh, sets are unordered, so we can't do that. We can't index them.
Oh, so what do we do in Python for set then?
Um, I think it's a set of one element, so I think we can do pop. Pop should work, I think. Pop.
Oh, okay.
Pop or get. Pop or get.
Pop and then dot val. All right, yeah, it looks like
Uh-huh.
it. I can see the IntelliJ or not like the intent sense there. Good.
Right.
So we did get what we want there. Let me just quickly do the test of the original tree that I had.
Right.
I had node 1 is node 1. We have 2 there. Let's do 3 and 4,
3 and 4.
and then just kind of put it together. What do we do? So we have node 1. Um, Actually, I'll just do node 1 here again, and then there would be node 2, 3, and 4. Node
Correct.
2, node 3, node 4, and then I remove the 1 on the top there. Would that be all? Yeah, I think that's it, right? 2, 3, 4,
Yes.
and we just pass in. Oh, the input here. We need a. Oh, actually, 2 would be. This would be node 2. We don't that no longer is. So for node 2, maybe node 1 in the middle, node 4, and node 3. This looks good to me. I don't know why there's some squiggles in there. Oh, I know why. Put 2 there. I think we're good. So
Yeah.
if I run this, I should get 1, right?
Correct. Correct.
Yeah,
Yeah.
do
1.
it. Let's do it. Great.
Yeah.
Yep, I think this program works. That's good. If you can tell me the complexity of this algorithm, then we can wrap it up soon.
Sure. Sure. The complexity of this algorithm, so starting with runtime complexity, I am iterating over the tree, and my tree is an array. So for each node, I am checking the children. So So, oh no, I'm for each node, I'm I am iterating over the children. Um, so what is the complexity here? So my outer loop. So if my tree has n nodes, my outer loop runs n times, and then my inner loop runs for the number of children of each node. So yeah, I'm not sure how to describe the complexity of the inner loop, because the inner loop will sometimes run if the node has children, and it sometimes won't run if the node has no children. Um, so
Right.
on an
Yeah.
yeah.
Yeah, it can be a little confusing there, especially with the double for loop. It sounds like n square, but then, like you said, sometimes there isn't a child loop, a node there. The best way to think about this is to ask yourself, how many times will a node be visited ever, right? You know that there's the input array, which goes through each node once. So every node will be
Mhm.
visited at least once, and
Correct.
every node except the root is a child of something. So it will be
Mm.
visited just once as a child. So the upper bound here is every node will be visited twice at most. And so because of
Mhm.
that, it's still a linear time runtime, because um, node traversal is just to end, right? So that would be a linear
I
time
see.
traversal.
Right. Okay.
And the space here, if you can tell me what is the space?
Yeah, the space would be, I'm using extra space because so tree is already known to me. Child nodes is n minus one, so I'm creating a set there. Um, so since I'm creating a set, my upper bound is O of n because I'm creating a set.
Right.
But yeah, so yeah, upper bound is O of n extra space.
Yeah.
It's an extra
Yep,
space
that's
I'm
right.
using here.
Yep, that's right. So this is a linear time, linear space implementation, which is fair. But there is actually an even better solution, and I'm going to explain that. I
Mhm.
don't think we have time to code it. And the the optimal solution, or a slightly better solution, is a constant space solution. Now, sometimes
Mm.
things don't come for free, right? If you want to save on the space, you have to spend a little bit more on the time. So for
Mm.
this problem there, we're going to spend a little bit more on the time. However, it's still
Mm.
going to be linear time, right? So asymptotically it's the same, but we can actually remove the set comparison or any kind of data structure to do it. And the way to do that
Mm.
is to make use of another characteristic of this problem, which is that every node has a unique value, right? It turns out
Mhm.
to be very important here. So what we would do here is that we would sum up all the values in the first pass, right? So
Mhm.
1 plus 2 plus 3 and all that. Now, as we iterate through this loop to sum up the values, we are also going through the children of every node and subtracting the sum from those values, right? So what happens is if I visit one, I'm going to sum up the value one into my variable sum, but then at the
Mhm.
same time I'm going to subtract 2, 3, and 4 from the sum. And then
Okay.
when you go to two, you add the two back, but then you're subtracting 5 and 6. But then when you visit the
Mhm.
5 and 6, you add it all back, right? And so what happens is
Mhm.
after all that, you will end up with the value one as your final
Mhm.
sum, because sum doesn't have a child, right? And so what happens is in your next pass, you just compare which node has the value one. When that node has the value one, you know that's the extra node, and then you return that node. So that way you're using
Oh,
one variable to track the sum, and you don't need to use any kind of extra data structure to track to tell the difference between a root node versus a non-root node here. So that is more
right.
of a follow-up question. Once you get this problem, which you did, if we have time, I would be kind of asking you this follow-up problem to see if you can further optimize the space. Sometimes,
Mhm.
the interviewer may not ask that because this is a little bit of a trick question. It's not
Mhm.
quite, algorithm type of thing. But I just want to explain that to you since you've got the first part. Just want to give you the second part as well. And just overall feedback about this question here. I really like our kind of discussion. I really like the way you problem solve this problem, coming up with different strategies, identifying a data structure, even without knowing what it is. you know that that data structure will be able to help you distinguish between the root and a non-root node. And you're able to implement a solution that is linear time and space. One could use a map as well. Instead of a set difference, you can use a map, but again, same space complexity. So it doesn't really matter which implementation it is, as long as it works. So at the end, you're able to solve it within reasonable time, 20, 25 minutes here. I know I had to write a little bit of the unit test there, but that's just because we don't have enough time. But if you were to do it, I'm sure you can do that too. So that's again, nothing negative that stood out for me in this problem. I think you're able to reason your way through, able to identify the right data structure to solve this problem in a reasonable amount of time. And the good part about this is you're able to express your thoughts along the way. So that was good.
Cool. Thank you. Thank you for your detailed feedback. This is very helpful. I just had one last question. So instead of the set, you said I can use a map there.
Right. Dictionary, yeah, in Python. Dictionary, yeah.
Yeah, dictionary in Python.
Yeah.
I'm trying to think what would be my approach if I used a dictionary.
Yeah. So there's also a couple ways to do it using a dictionary. The simplest way would be you traverse the input, right? And every time you see a node, all you do is you put the children of each node into the dictionary, right? As in, this dictionary keeps capturing all the child, right? And so when you when you go through the input array and storing all the children in there, that dictionary will have all the nodes except the root node, right? And then you do a second pass and check, does this node exist in the dictionary or not? If it's not, then you know that's the root node. So the dictionary is for you to track whether it's a child node. It's to help you track all the child nodes.
I see. So child nodes are added to the dictionary, and in the second pass, I can check if I can then filter out a node which is not in the dictionary. So that is my root node. Got it.
Right.
Got it, yeah.
Again, the subtlety here is that every node has a different value. So that's why you're able to do that, right? If two nodes have the same value, then you can tell, right? In that case, you have to store something else. Maybe you have to store, the address or something. It gets a little complicated that way, but it only works because of this. So and then once you see that you can compare nodes like that, then you can figure out maybe you don't even need that data structure altogether, right? Using the sum as a way to replace the dictionary. So the first solution kind of leads to a more optimized solution. But I think for the most part, this solution, a linear space solution, will suffice as well.
Cool. Thank you. Yeah, this was great. Yeah, thank you for your feedback. It was very nice and very helpful. Yeah.
All right, great. Thank you for using interviewing.io today, and I hope you have a great rest of the day.
Yeah, you too, and thank you for your time. I really appreciate you taking the time to interview me. This was very helpful for me. Thank you again.
Yep. All right. See ya.
Yeah. Have a nice day. Yeah. Bye-bye.
Yep.